Hi everyone, so in this episode we'll be having a look at procedurally generating planets and terrain to create beautiful looking planets we can explore in our game. So I had a look at some of the videos of Sebastian Laig's awesome tutorial series about this topic and also this other YouTuber who actually translated his project to the Godot engine. However, this video is based on the old versions of Godot. So now I'll be showing you my approach in the Godot engine 4.3 version. So I need a sphere to begin with, and even though I could use the basic mesh sphere from Godot, I decided to use another sphere type just to be able to have more control about the sphere, so I implemented this version called Humble Sphere into the project. So to create this Humble Sphere, I create a new empty scene, which I'll just call Planet 2 here, and then I added these mesh faces for each of the face, so I'll just call this one up, and I'm going to save the scene here somewhere. I may edit these scripts to all the faces, which is just a tool here, so it means it runs in the editor. So I just take that script, and for more or detailed explanation, I'll highly recommend you check out the other tutorial of the second guy, because this is basically his script but translated to Godot 4.3. You can also find this in the bio. So I have this script here for one mesh face, which is just generating this mesh of one side determined by the resolution, and we're just going to add it as a array mesh here. And because it's on the upside of the cube, we just add this y variable to +1. That's actually, and I'm doing this for all the faces. So for example, down is on -1, left is on -1 on the x-axis, right on the 1, and front on the z. So just duplicate this script here for the others and just name this like down and set this to -1. We rename this to test, and as well the -1 here, and as well the right or the 1 and 0, and then we have the front with negative z and the deck with positive z1, this and 0 again. And this is just because of the script we've applied here. And now I have these standard mesh faces scripts on all these meshes, and there is a planet script which I just call planet, and here basically I have this ledger function which emits a signal to his children with the planet data. So in the planet data I stored my information about the planet, like the radius, the resolution, and the noise, which will I later add to better terrain, and just some other parameters. This planet script is applied to the planet node here, and now since this planet node contains this planet data script as a object, we have this one here, and we gotta create a new one right here. So again, check out these tutorials if you want to know more about this script, but just for simplicity I'll just add these below on just the GitHub repository, and you can just copy it over via Godot project. And now I have these parameters here which allow me to control my sphere. So I have this radius set to 1 here, you can basically do 2, and now we actually get our here. So I have this sphere here, and now you'll notice when you just will see these little gaps between these mesh faces, we just incline the resolution just over here, and we'll see like these go away. And now we have this perfect sphere. Can look and edit in the wireframe perspective, and we have this even distributed triangles here, which I can use then to create the planet. So this is the code to create this sphere, where we can determine the number of vertices with this resolutions variable here. Implement some terrain on the planet so it actually looks like the planet. One of the most common ways is to just use noise, which is a random generated looking map or texture map, which looks like this one, where we have some grayscales where white represents 0 and black represents 1. So we can have these displacements with the different grayscales. So in the planet data script, there is this array of noises, so we can actually layer these noises to create some more advanced complex systems of mountains. So we have these collections of these textures, and how we implement this on our sphere, we're using this function here, which just returns a point on the planet given by a vector. So we have this variable where we set the basic elevation to 0, and then I have also the space layer mask, which is just to provide that if layering the noises, there aren't any random mountains just spawning in the ocean are elevating from the ocean to the surface. So I have this planet noise array here, and we'll just go through the planet noises, which actually this array refers to this planet data component array right here, where I can just set this array number to something like 3, and then I'm able to create 3 noises on top of each other, all with just some different specifications in this array right here, where I can determine the size of stack noises. These planet noises are a separate class created in another script here, where I have the amplitude, the minimum height, the actual noise map, which is this fast noise light in 3D. You can see here these variables, amplitude, noise, and this base layer rule. We just determine the base layer because of this ocean mountain problem. Then this is all in this array right here, all concluded in the planet data. And then I'm going through all these layers here and just setting this base elevation by just taking this function from noise map here, from n, the noise map, and this getNoise 3D Lee gets us this value between 0 and 1, and here is just a multiplicator to scale it up a bit. Then I'm just dividing this elevation with the amplitude in here and the min height to set these values with more control about this, and then I'm adding it just to this base layer, and after looping through these I get the base layer elevation, and again just basically that's the same again, but I'm just going then through the other all layers and calculating this all elevation, and then I'm just setting these elevations here which I have, and then I'm just returning the point on the sphere times the radius. That would actually be the surface then, and the elevation +1 because we don't want to be on the surface, because then we get the null error. And then we return this point, and then in the planet mesh phase script of every phase, there is this function where here we actually create the sphere from the cube, so we turn it around, and then we make this variable for the planet, where we just take from our planet data the point on planet, and we just set this point, so that's just a point on the sphere, and then we'll return the elevation. So we then set the vertex array .I, which is the vertice on this point, to the height of the point on planet. And so we actually apply these layers to the script. And now I can create one of these noises here. And I'm saying this is the base layer, and I can just build up this amplitude a little, and we'll see these coming out of here, this texture and stuff. Just bump up the resolution, make it a little more clear. And so going down a bit, we can just play around here with the frequency as well. So if we put up a high frequency, we'll get this spikes right here. Or here we just get some base layer terrain eruption like this. Just controlling this. I have these art like this here now. Like something, I'm just scaling it down even further. I just up a bit to get these here, and then I can just use this amplitude to control it even further and just make some complex layers of terrain on planets. And all that's left to do to get to the point where I was after watching these 3 tutorials. So I have this planet color, which when looking at the script again is just here in the planet data, just a gradient texture 2D, which I can just create a new gradient, and I actually get this. So to use this and just to color it based on their height, just going through these planet mesh phases, and again in this planet shader right here, and I've created this planet shader, which is applied on the material override on every phase, on every mesh phase. So basically, if I would just remove this here, mesh phase would be white again, and I get this. So that's the code for the shader right here. You can go ahead and copy that if you'd like to have this determined by the height. So this gradient just is applied determined by the height. So basically I can just add some colors here, and I could place a color right here like this one, and then so it's in the middle, and in the middle we have this thing which fades into the white at the end, and the leg, which is the lowest layer. And with these simple steps, I created my planets in here, and also could bump up the resolution. So that's the base layers and how to create these planets. In further videos, I'll definitely just advance these scripts so I can actually use a level of detail system when the player is near, so it has a higher resolution for my other projects, and also add biomes to the planet and lots of other stuff. So definitely check these videos out if you want to create this more advanced planets. So now you can just use this little tutorial here to create your own planets, and hope we'll see you in the next video.